Hey everyone. So, as we were looking at 1010 pairs of songs with total duration divisible by 60, right? Um, so, we discussed the solution where we'll be looping through the times like of n square times, and then we'll be whenever we encounter um, a pair which is mod of 60 is equal to 0, then we'll be incrementing our number of count. So this is okay, but it's not that efficient. So there is one another approach which I was not able to understand or comprehend exactly how it's working. So the idea behind is it's that we need to account for so how should I see this? So let's say we are let's go on the Miro board and let's take this example of, let's see which all. Oh, lots of companies like to ask this question. Okay, anyways, we'll take this example wherein 30, 20, 150, 100 and 40, right? So these are our example. uh, okay, I found you. Okay, hopefully this is visible. And then what we are trying to do here is that, let me get this microphone real down. Okay, so what we are trying to do here is um, so we oops, sorry. Okay, let me keep it this way. Yeah, so here let's say we are um, we are finding if the number of, if these timestamps that are given to us is divisible by 6. Okay, let's say 6. So what we are considering is we are creating an array of 6 length 6, 1, 2, 3, 4, 5, and we are assigning everything to be 0. So anytime if you divide a number which is divisible by 6, then it will surely uh, it will be always less than the 6 element. So for example, 30 is divisible by 6, right? So 6 5 is 30, so this remainder is 30. So this mod always gives us the remainder. 30 mod 60 will give us remainder 0. So this 0 over here signifies the remainder, and then we can simply uh, update that count uh, whenever we encounter a number which is getting divisible by 60. 6 for in this example we are looking for divisible by 6 or not. So yeah, uh, so if we see this, what she's trying to say is that let me, can I zoom this? No, I cannot zoom this, right? Okay, so what she's saying, if time of I, if we are looking at a time it is divisible by 60, we simply calculate the v of 0 meaning um, the remainder 0 where we are incrementing the count. Will simply add that count, add whatever value is here to our count. Okay, so else we need to check how far it is how far t of I, like time of time, is far from next multiple of 60. For example, 100 is 20, far from 100 is 20 far from 120, which is multiple of 60. To achieve this, we do two steps. If time of mod of I is not equal to 0, this means remainder should come between 0 to 59. Okay, this will all make sense once we start to go through our example. Now we check how far is time of I mod 60 is far or less from 60. From this, we simply subtract 60 minus remainder and check and add its frequency in answer. Then we simply increment time of I mod 60 frequency, return answer at the end. So anytime we mod anything, let's go back to our example and hopefully I can explain it better. But anytime we mod something with a number, it will always be less than that number. So that's one rule. And then okay, so uh, what we are doing is we have a, let's say we have our count, and then count is initially 0. Okay, so the okay, so 0 1 2 3 4. So what we are doing is we are just traversing through the numbers. So initially we go to 30 and we mod it with 6. 30 mod 6 is 0, so we'll go to 0 and we'll add that value to our count. So what is the value of count here? It's 0. So we'll simply add 0 to this count, uh, which will be nothing but 0, because at this stage we just have one number which is divisible by 0. We need to actually find two numbers, a pair, which will on adding them it will be divisible by 6, right? So that's why this works. So we add 0 and next we go to 20. Then 20 mod 6 is, so bear with me, I'm bad at math. So 6 3s is 18, then the remainder is 2. So what we and okay, pardon me, I we also once we add 0 here, let's go back to the last previous step. Once we add this remainder's value to the count, we also need to increment it. So we increment this count and then we move on to the next, which is 20. We mod it and then our mod is 2. So now what we need to check is how many so why are we doing this 6 minus 2, like the mod that we get? Why are we doing this? So the answer is simple, like we are just checking how many numbers did this 20 fall short if it was supposed to be a divisible of 6. So if you see, 6 minus 2 is 4, and here the 20, if you see, 20 is falling. If we add this 4, let me take a different color. If we add this 4 to this 20, then that would be 24, and 24 mod 6 is 0, like yeah, I hope that's right. Yeah, that's right. Okay, because 6 forza is 24. So yeah, so that's why we are doing that. And then what we see is uh, we try to find if there is anything on 4 like this. We minus it, like we minus 6 minus 2 is 4. Then we check if there is something, like we go to this index and we simply add it with onto the count 0, so it's 0. And then we simply update whatever the remainder that we got. We update that count to 1, and then we move on to the next element, which is 150. Then here the remainder was 2, and then 150 mod 6 is, so 150 mod 6 would be I guess 2 is 12, 35, and it's 0, right? We can find 0, so it's 0. So at this stage what we'll do is we'll take that 0 and we'll see, and we'll take this index value and add it to our count. So that means that we found 30 plus 150. We found our first pair. 30 plus 150 is 180, and it is divisible by 6. Okay, so we found a pair, then we add 1 because here is 1, and we increment the count of 0, which is 2, because we found two two numbers here, and then we add 1 here. So yeah, and then let me get rid of this this guy. Yeah, let's keep it clean. And then we go to 100 mod 6 is equal to what it will be. Then let's see, it will be 1, then 40, right? And then the closest is 6, 36, 4. 4 would be the mod answer for this guy. Okay, so we got the what mod will be of this. Then 6 minus 4 is 2. So if it would have 2 more, a value of 2 more in this, then it would have been a multiple of 6, right? So yeah, that's that. And then what we can do is we can simply check if we have anything on index 2. So yes, we have something on index 2, and we add it here, and we update this count 1. So basically on 2 what we had was 20, and 20 was waiting for some value to which if we add it will be divisible by um, divisible by 6. So that's what we do here. We see if there is any value that if we add to this, that will increment. So yeah, if that makes sense. And we'll definitely increment the count of 4. Yeah, we did increment the count of 4. And then let's go to the 40, and mod 6 is equal to 36, and again there is 4. So let's add whatever there is on on 4. So I think I messed up somewhere. So there is 30. So 30 and 150 is divisible. Then this guy is divisible. Then with this guy, what is divisible? Like yeah, uh, 10. Okay, yeah. So we got 4. Then what we do is 4 6 minus 4 is 2. Then we simply add plus 1 here, and we increment the count of 4 to 2. Okay, and then we simply have now equal to 3, so we return this 3 value. But yeah, we need to do that same thing for this 60. That's what she has explained here. uh, Now we check how far is time of I. Time of I mod 60 is far or less from 60. For this we simply subtract 60 minus remainder and check and add its frequency in answer. So that's what she's doing. See, if she is calculating the remainder, if remainder is 0, then she is directly adding whatever is there in the uh, on the 0th index. Else she is checking the if 60 minus a, how many uh, if there is something here, uh, then yeah, she's adding that as well, and then always incrementing whatever value that we got. We are incrementing its count. So I know this is not very intuitive. I also learned about this thing today, uh, like how we can do the mod and difference between that and other stuff. But yeah, it's not very intuitive. I came up with the O of n square solution on my own, but this is like if you solve it like once, twice, thrice, I guess it will come to you naturally. Other than that, I don't know how. If I think you need to be too good in maths for coming up with such solution on your own. But yeah, that's nice. Other than that, let's code it out. um, so basically we don't have to do much here. We have to create a let um, array. Let's call it array of length 60. So our time complexity, our space complexity is constant. For let I is equal to 0, I is less than times, or we just need time, right? Time of t of time, let's call it t of time. And then what we do is let remainder is equal to we calculate it with the help of t mod 60. We get the remainder of this, and we check if remainder equal to 0. Then what we do is array of 0, we add it to the count plus equals to array of 0. And else what we do is count plus equals to, we check if whatever the remainder, do we have So what do we call it, like 60 minus remainder? um, so we'll check if we have anything to be added to this value which can result into a number which is divisible by 60. That's what we are doing here, right? For So we saw an example of uh, let's say 40. Here we okay, let's say 20. 20 mod 6 is 2, so we increment 2 by 1, right? And and at that point we check 6. 6 minus 2 is 4. There was nothing on 4 at that point of time, so that's why we didn't add anything. So we came on to as you know, 100 plus 20 is 120. So what we did here was 100 mod 6 is 4. So we need to find a number. We need to find a number on which, if we add it with 100, it will be divisible by 6. So the way of doing it is we check it by 6 minus the remainder that we got after dividing 100 was 4. So we check if there is anything which can make our 100 divisible by by 6. So we subtract the remainder with our divisor, which is 6 here, and we get 2. So we um, go to the second position. I guess I did something wrong. Okay, yeah. We go on to the second position, and there was 1. Then we add that 1, and that's how we know that these are, you know, divisible by 6. Hopefully that made sense, and then if not, then it's okay, it's fine. Um, and we'll also update the array with whatever remainder that we got plus plus. Okay. So yeah, that's it. That's about it for this solution. Let's see. Okay, wrong answer. Why is that? Oh, we need to also fill it with 0. Okay, yeah. Now it was accepted. So this is of n solution. So the next question that we'll be looking at will be this guy, minimum absolute difference. Let's see what it is and keep on solving all these questions and see how it goes. Thank you so much for watching.